Hello everyone, Dan here from Waygate Technologies, and welcome to another installment in our series on the USM 100 portable flaw detector. Today I'd like to show you a little bit about our 2-point calibration features. We're going to look at two different ways of doing this. In the first, we're going to look at using a straight beam probe on a traditional step block. Show you a quick way to get that dialed in. And then we'll look at an angle beam probe on our DSC calibration block. Alright, so we'll start from scratch here. Launch our provided conventional app. Start from the beginning. I've selected a 5 megahertz gamma probe, so there's not a lot to change about the probe setup on this. The default value is already 5 megahertz, but we can come in here and look at the probe setup. Because we're going to be doing a straight beam calibration on a steel block, the default velocity of 0.23 inches per microsecond is going to be close. The probe frequency is already selected at 5 megahertz, so that's going to do a good job of setting the pulsar width. This frequency control in the probe menu deals mainly with the calculation of pulse width for our square wave pulsar, so optimizing the pulsar to work with the probe. The filter selections are over here in the UT menu, and we see that's already set to 5 megahertz. Okay. So we're in a good starting point. Let's put a little coupling on our block, and we'll just look at 1 inch here. So we can take our gain down some. We'll use the auto 80 function to get the gain on the 1 inch block in gate A nicely at 80%. Let's close that, and we'll go to our 2-point calibration menu. And I'll swipe out my sidebar. I'm going to calibrate on the 1 inch thickness, so we'll change that to 1 inch. And I'm going to make use of our multi-backwall calibration. So this allows us to do the calibration in one quick step. I'm going to drag my gate B here so it's about the same place on the flank as gate A. And all I need to do is hit the calibrate button, and our calibration completes. And it looks like we measured 0.2328 inches per microsecond of velocity and 0.332 microseconds of delay. Notice our reading up here for sound path in gate A is rated at 1 inch, 0.999. Get a little more coupling on here. So there at 1 inch, 3/4 of an inch. Let's drag our gate A here, make it a little wider, so we can measure over the range. 1/2 inch and 1/4 inch. So our delay and velocity calibration completed as we expected. Okay. Now let's switch over here and let's take a look at an angle beam calibration. So change out our probe. Set up. Now we're going to need to change a couple of things because this is in fact a 2¼ megahertz probe. So let's go back here and set up. Go to our probe menu. First thing we ought to do, since we're going to be working in shear wave, is just change the ballpark figure for our velocity to get us in the general area of shear velocity in steel. I picked 0.13 there. Let's take a look at our probe frequency. We'll set that to 2.25 to better optimize the pulsar for this probe. And we're going to go to the pulsar receiver menu, and we'll change our filter to 2¼ megahertz. And we start to see now our echo from the Let's take our gain up, change our dB step to some coarser steps, 6 dB steps for now. Give the gain tap on the back. Okay, and here's our echo from this 1-inch radius of the DSC block. Now the DSC block gives us a 1-inch radius and a 3-inch. If I turn the probe around and shoot this direction, I get 3-inch. When I'm on the 1-inch, I actually get an echo from 1 inch and also an echo from 5 inches. So 1 plus 3 plus 1 gives me 5. So now if I extend my range out to, say, 8 inches, there's my echo at 1 inch, and I have an echo out here at 5 inches. So let's close that. We'll swipe out our sidebar, and we're going to go to multi-step calibration. And we're going to tell it that we want to have our first reference at 1 inch. We're going to do our second reference at 5 inches. Okay. We can drag our gate over the echo, and let's get that up to 80% screen height. Use the auto 80 feature to bring that up. Get it peaked up there. Okay. All right. So now we can go ahead and do our calibration. Let's close that. Close that. Let's hit our cal button. And it says show me the 5-inch echo. So let's come out here. Get some more amplitude. Gate over the 5-inch right there. And hit cal. And it calculates the velocity at 0.1278 inches per microsecond, and our probe delay at 3.19 microseconds. So now if I go back to my 1-inch radius, I'm just a little bit shy there. Depends on the exact placement of the probe. And our 5-inch. And right here is an echo that is about 3/8 of an inch inside the back wall from an EDM notch in the back of in the larger radius of the DSC block. Okay. So that gave you a look at 2 different methods for doing velocity and delay calibration on the USM 100. Took a look at the straight beam probe on a general purpose step block. We use the multi-back wall method for that. Do it all in one step. And on the angle beam calibration, we used the multi-step calibration, showed at the 1-inch separately from the 5-inch. Quick and easy to do the delay and velocity calibration. So thank you very much for joining me. As always, if you have any questions about the USM 100 or technical questions on any subject, please reach out to remote service at bakerhughes.com, and we look forward to hearing from you. Thank you.